Hi there. I'm going to have another demo for or our apps and massive MIMO order, namely let's say 64T64R, 32T, 16T, 8T, and so on and so forth, is going to be changed as a function of the cell loads. And in our X apps, now we can see the aspects of the energy, power energy consumption and energy saving percentage after using our X apps. We have in the configurations of for the cell as three different cells, and as it can be seen here, NR 3600 or 5-unit radio has been used for all the cells and the area, and these are the configuration of the power of the cell and the azimuth and the height and tilt for the antenna. And here, as it can be seen for 5G new radio, bandwidth is 100 megahertz, and the numerology 1 has been used, and central frequency can be seen here as well. Now, what's going to be done is that, first of all, let me take a look at advanced RF model, traffic model, RF model. This is based on the TDD. And now I'm going to run the simulation. It's a VIA-VRIC tester for testing the near real-time RIC and non-real-time RIC and or X apps. This is the X apps that has been defined, and now we are going to see, let's say, some figures here and what's going on after running or our app. So at the first stage, let me run the simulation, and at the meanwhile, I'm going to run or our apps. So it's going at the first updates. It has jumped to 32T, 32R from 64TR, and as you can see, these are the updates of the power for cell 1, S1, B39, C1, and these are the average power for this cell, and as you can see, dynamically can appear in the figure here, and the load is going to be is changing, and as a function of the changing the load, we can see the power consumption in the cell changes. And here we have another criteria to consider the energy consumption of our cell. We already defined a percentage, and for example, we can see here that power saving percentage is 51 percentage, so it's a good value here by using our apps. This is a 57 percentage, and so on and so forth. And it shows that how our app works properly for and we have designed this R app for just control S1 B39 C1 cell site, and at the end it's going to be updated, and the values as a function of the cell throughput, and it's jumping from the 64T to the other lower order of the massive MIMO, and as a result we can see how let's say the energy consumption is decreased. And this X-apps also now we can see here, for example, for the latest update, it's 66% for the power savings. That's a great value after using our apps. And just I'm going to show you because the let's say that cell throughput variation for different let's say changing in the massive MIMO order through the changing the antenna mask as a function of the cell traffic load, and it can see here its impact. And let me make larger it. And here, as you can see, when the cell threshold is defined for a specified value, we can see that we have 6040, 64R massive MIMO order, so the cell throughput is high. And also for the cases that the cell, let's say, traffic loads is decreased, we are going to power off or turn the massive MIMO order to the lower one, and consequently you can see that the cell throughput has been decreased, and we are waiting till the end of the simulation, and these are our updated charts. It's dynamically showing how much power let's say consumption is for different time periods, updates for different massive MIMO order as a function of the cell traffic load. And the simulation duration is about near 5 minutes, and now it's going to be stopped, and after that we will close this demo, and we can see our last updates, dynamic updates. Thank you.